Good morning, students. Today again I want to continue the examples on inverse trigonometric function 2.2 exercise. Find the value of sine inverse of sine 2 pi by 3. As you know that sine inverse of sine theta equal to theta if theta is lies between minus pi by 2 to plus pi by 2. See, some of the students directly they are writing 2 pi by 3, but it is not correct. Why? Because theta should be lies between minus pi by 2 to plus pi by 2. So 2 pi by 3, 2 pi by 3 equal to how much? 120 degree. It is more than 90 degree. It means it exceeds pi by 2. Then you cannot write 2 pi by 3. That is why you have to make that angle in minus pi by 2 to plus pi by 2. Therefore, see what I will write now. Sine inverse of its value should be lies between minus pi by 2 to plus pi by 2. Why? Because range of sine inverse of x is lies between minus pi by 2 to plus pi by 2. Therefore, here see sine of 2 pi by 3. See this theta you have to convert in terms of minus pi by 2 to plus pi by 2 by using allied angles. See, sinus of 2 pi by 3. In which quadrant it is positive? In second quadrant and first quadrant. Therefore, here I want to write sine inverse of sine of pi minus pi by 3. See, this 2 pi by 3 can be replaced by pi minus pi by 3. Is it correct or not? See, simplify it. So pi here denominator is 1, 1 3 is a 3 pi minus pi, 2 pi by 3. So it means 2 pi by 3 can be written as pi minus pi by 3. Yes, you know that sine of pi minus theta or 180 minus theta is equal to what? Sine theta by using allied angles. Therefore, we can write it as sine inverse of sine pi by 3. Now it is lies between minus pi by 2 plus pi by 2. Therefore, by using this property, you can write it as pi by 3 or 60 degree. In this way, you have to write the answer. Directly, you cannot write 2 pi by 3. Sinus of sine 2 pi by 3 equal to pi by 3 is the answer. In this way, you have to find the value of inverse trigonometric functions. Second question. Second one is tan inverse of tan 3 pi by 4. Before to find the value of this one, first you should know here we have a tan inverse means its value should be lies between open bracket minus pi by 2 to plus pi by 2. Whenever you have tan inverse will come in the first, it means its range should be minus pi by 2 to plus pi by 2. Why? Because it is a range. Therefore, here what about 3 pi by 4? 3 pi by 4 equal to 135 degree. It means more than pi by 2. Therefore, directly you cannot write 3 pi by 4, isn't it? Not necessarily write like this, isn't it? Therefore, again I want to convert this theta in between minus pi by 2 to plus pi by 2 again by using allied angles. Therefore, here also see tan inverse of tan of 3 pi by 4. 3 pi by 4 can be written as pi plus pi minus pi by 4. See, 3 pi by 4. It means what? Pi minus pi by 4. Because if again here you have what is the LCM? 4. 1 4 is 4 pi minus pi is 3 pi by 4. 3 pi by 4 can be split as pi minus pi by 4. Again, you know that tan of pi minus theta or 180 minus theta equal to what? Minus tan theta. Therefore, you can write it as tan inverse of minus tan pi by 4. Or you can write it as you know that tan of minus theta equal to what? Minus tan theta. Therefore, this I want to write it as tan inverse of tan of minus pi by 4. Or you can write tan inverse of minus x as minus tan inverse of x. So by using that property also, you can simplify. Otherwise, tan of minus theta minus tan theta, they can replace tan of pi by 4. Now minus pi by 4 is pi by 2. Therefore, you can write it as minus pi by 4 is the answer. Third example. Third one, cos inverse of cos 7 pi by 6. Cos inverse of cos of 7 pi by 6. So what is the range of cos inverse? Its value lies between 0 to pi. Already know that. In this interval only cos will be exist or it is invertible. 7 pi by 6. Pi by 6 means 30. 30 is 3 7 that 210. 210 is 210 means more than pi means directly you cannot write 7 pi by 6. Again we have to convert this one into lies between 0 to pi. Again you see, because its value is lies between 0 to pi, then only you can write theta here. Therefore, here also cos inverse of cos of how to split 7 pi by 6, pi plus pi by 6. Okay, see again here what we have to, how to split this 7 pi by 6, pi plus pi by 6. I want to convert the angle between 0 to pi by using allied angles. Simply cannot split like this. Okay, so 180 plus theta, 180 minus theta, 90 plus theta, 90 minus, like that. Allied angles, you know, already know that. So here you have cos means, here also should cos means either you have to take pi plus or minus theta or 360 plus or minus theta. What about cos of 180 plus theta? 180 plus theta, it is in third quadrant. In third quadrant cos is negative. Therefore, you can write it as cos inverse of minus cos pi by 6. Why? Because cos of pi plus theta in third quadrant cos is negative by allied angles. Again, you know that cos inverse of minus x can be written as pi minus cos inverse of x. This property already we proved here. Therefore, cos inverse of, in place of x here, pi by 6 is there. Therefore, here I want to write pi minus cos inverse of cos pi by 6, because in place of x here pi by 6 is there. Pi by 6 is there. Therefore, cos inverse of minus x equal to pi minus cos inverse of x. Now here we have cos inverse of cos theta. Theta is lies between 0 to pi because it is 30 degree. Therefore, you can write it as pi minus pi by 6 by using property cos inverse of cos theta equal to theta if theta lies between 0 to pi. Therefore, here we have 5 pi by 6 is the answer. And right, in this you have to calculate the value of inverse trigonometric functions. Next is sine inverse of sine 3 pi by 5. Sine inverse of sine 3 by 5. Sine inverse of sine 3 pi by 5. 3 pi by 5 equal to how much? First, its value should be lies between minus pi by 2 to plus pi by 2, you should know. It means sinus of sine theta equal to theta if theta is lies between minus pi by 2 to plus pi by 2. But what about 3 pi by 5? So this is equal to 3 into 180 by 5. 5 ones are 5 threes are 15, 5 six are, this is equal to 108. Therefore, it is again more than pi by 2, means you cannot write directly 5 pi by 6. Again, therefore, here I want take it as sine of pi minus 2 pi by 5. First, I want to split this 3 pi by 5 as pi minus 5. Is it correct or not here? Because what is LCM here? 5. 1 5 is 5 pi minus 2 pi, 3 pi. So here I can in terms of allied angles as pi minus 2 pi by 5. As you know that tan of 180 minus theta, 180 minus theta, second quadrant sine is positive. Therefore, you can write sine theta. Therefore, here we have sinus of sine 2 pi by 5. Now it is lies between minus pi by 2 to plus pi by 2. Therefore, you have write it as 2 pi by 5 is the answer. Next question. Next question. Cos inverse of cos 7 pi by 6. 7 pi by 6. Already you know that cos inverse value lies between 0 to pi. Range of cos inverse should be 0 to pi, means 7 pi by 6 means again it is 210 degree. It is more than 180 degree. Therefore, you cannot write directly 7 pi by 6. Again, I want to write this as cos inverse of, sorry, 7 pi by 6 is over. Now it is 13 pi by 6. 7 pi by 6 already are discussed here. Cos inverse of cos 13 pi by 6. Already 7 pi by 6 is over. 13 pi by 6. Okay. Therefore, again it is 13 pi by 6 is more than 0 to 180 degree. Therefore, you cannot write directly 13 pi by 6. Therefore, here cos inverse of cos of 2 pi plus pi by 6, because 13 pi by 6 can be split as in terms of allied angles 2 pi plus pi by 6, because again what is the LCM? 1 2 the 6 2 the 12 pi plus pi 13 pi by 6. As you know that 13 cos of 2 pi plus theta equal to cos theta. Again it is in first quadrant. In first quadrant all the trigonometric functions have positive sign. Therefore, here we have cos inverse of cos pi by 6. Therefore, what is the answer here? Pi by 6 is the answer. Next question. Next is again tan inverse of tan 7 pi by 6. Next question. Again, tan inverse value lies between 0 to, sorry, minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. It exceeds pi by 2. Therefore, directly you cannot write. Again, I want to write in terms of allied angles. Therefore, here tan inverse of tan pi plus pi by 6. Why 7 pi by 7 pi by 6 can be split as pi plus pi by 6. Again, you have to apply the allied angles 180 plus theta. So 180 plus theta it will comes in the third quadrant. In third quadrant, tan is positive. Therefore, directly it will become tan inverse of tan pi by 6. Now this pi by 6 is lies between minus pi by 2 to plus pi by 2. Therefore, your pi by 6 is the answer. Okay, so these are some example. So find the value of the inverse trigonometric functions. Still some 2-3 questions are remaining in the exercise 2.2. I'll solve that one. Show that again 2 solved examples are remaining in the exercise 2.2 that I want to finish it now. Show that sine inverse of 2x root of 1 minus x square equal to 2 sine inverse of x lies between minus 1 by root 2 to 1 by root 2. Again, one more example is sine inverse of 2x into root of 1 minus x square equal to 2 cos inverse of x, where x is lies between 1 by root 2 to 1. So these are 2 examples you have to prove here. See why I wrote that both the example in the same time, because you see the LHS. Sine inverse of 2x into root of 1 minus x square is in the first example, and second example also we have a sine inverse of 2x into root of 1 minus x square. But in the RHS side we have 2 sine inverse of x, 2 cos inverse of x. Okay. See in the LHS we have a same terms are there. In the RHS we have a different terms. See. So either you can take this one, simplification is it is same, but according to given data you have to take. That is very important, because in the CET also, so sinus of 2x into root of 1 minus x square, 4 options they will give. Okay, so it is 2 sinus of x, 2 cosinus of x, 2 tanus of x. Okay, in that what is the correct option? According to the value of x, you have to mark the answer, pick the answer, isn't it? Why they are given this one? In this interval only the sine or x will be exist. In this interval only both sine and cos will be exist. That is why they are given in the interval. We are not using that intervals. So all the examples they are given some values of x, intervals of x they are given. In that intervals only that x, sine inverse of x or cos inverse of x, tan inverse of x are exist, isn't it? So therefore you have to prove this is equal to this or this is equal to this. But in CET, suppose sinus of 2x into root of 1 minus x square equal to what? 2 sinus of x, 2 cosinus of x, 2 tanus of x, 2 secnus of x. In that 4 options, which one is correct? Means according to x, you have to select the answer. That is why I wrote both questions in the same time, isn't it? First, take this question. Sine inverse of, very simple it is, sine inverse of 2x into root of 1 minus x square. This is nothing but LHS. Okay, what you have to prove? 2 sine inverse of x is there. That is why here I want take care. See, put x equal to sine theta. Put x equal to sine theta. Theta equal to what? Here only I want to simplify theta also, because answer will comes in the variable x. Lastly, you have to write in the answer in terms of x. Therefore, this is equal to sine inverse of 2 sine theta root of 1 minus sine square theta. So this is equal to sine inverse of 2 sine theta root of 1 minus sine square theta cos square theta. Root of cos square theta is nothing but what? Cos theta. Therefore 2 sine theta cos theta equal to what? Sine 2 theta. Therefore you can write it as sine 2 theta. Therefore sinus of sine 2 x. This is nothing but RHS. This is the first example. Because in the RHS side we have both in the same both the examples have same terms are there. Here you have to take x equal to sine theta. There you have to take x equal to cos theta, because what you have to take that RHS side gives us what you have to make a substitution, isn't it? Here also take LHS. Sine inverse of 2x into root of 1 minus x square. Here put x equal to cos theta here. Therefore theta equal to what? Cos inverse of x. If you substitute here, we have sin inverse of 2 cos theta into root of 1 minus cos square theta. Root of 1 minus cos square theta is nothing but sin theta. Therefore here we have sin inverse of 2 cos theta into sin theta. Therefore this is equal to sin inverse of sin 2 theta. Again 2 sin theta cos theta. 2 sin theta cos theta is nothing but sin 2 theta. Okay, sin 2 theta. Therefore here you have sin inverse of sin 2 theta. Therefore what is the answer? 2 theta. Again theta equal to what? 2 cos inverse of x. Okay, according to RHS you have to make substitution for the same example, you get the answer. This proof also they will ask for 2 marks in the examination. And these proofs also we will use in the derivatives, differentiation and integration. Next question. So I took almost all examples of exercise given in the 2.2. Okay. See, some questions from miscellaneous I want to solve, because see, now this year whether we have a reduced syllabus or not full syllabus, you don't know. That is why suppose according to last year syllabus means only you have to practice exercise 2.1, not necessary to discuss 2.2. So I covered all the examples of 2.2 also. Suppose if they keep whole syllabus means exercise 2.2 also you have to practice, isn't it? And what now some questions I want to solve here, that questions usually CET or JW they will ask. CET means not the CET also they will ask from the reduced syllabus only. Therefore some questions I want to solve, they will ask in the JW. See, not direct that question, they will ask some difficult question only they will ask in the examination. How to write that small simple example I want to explain here. See, one more concept is what here. If you know one of the inverse trigonometric function, then you have to express one inverse trigonometric function into remaining 5 inverse trigonometric function. See, as you know that in the trigonometric function also, if you know one of the value of trigonometric function, then you can find the values of remaining trigonometric functions. Suppose if you have sine theta equal to 3 by 5. Suppose if you have sine theta equal to 3 by 5. It means how to find remaining, as you know that sine theta equal to 3 by 5 means here you have a right angle triangle, opposite side by hypotenuse and adjacent is 4. Therefore cos theta equal to 4 by 5, tan theta equal to 3 by 5, and reciprocal of sine cos tan you will get cosec secant cot. So if you know one of the value of one of the trigonometric function, then you can find the remaining 5 trigonometric functions. In the same way here, if we have sine inverse of x, sine inverse of x you have to express into remaining 5 inverse trigonometric functions, isn't it? One inverse trigonometric function you have to express into remaining 5 inverse trigonometric functions. Sine inverse of x equal to cos inverse of what? Sine inverse of x equal to tan inverse of x. Tan inverse of what? Isn't it? It means one inverse trigonometric function you have to express into remaining. If you know one of the inverse trigonometric function, then you can find the remaining 5 inverse trigonometric functions. Okay, one inverse trigonometric function you have to express into remaining 5. For example, cos inverse of what or tan inverse of what. In this way you have to express. How to express it? See, first I want to take here one in general sine inverse of x. How to express sine inverse of x in terms of tan inverse, cos inverse, sec inverse and cosec inverse? See, take here sine inverse of x equal to theta. What about x sine theta? Okay. Again, if you draw the diagram, right angle triangle, if it is 90 degree and it is theta, sine theta. Here if you have A, B, C. Okay. Sine theta equal to what? X by 1. Sine theta definition is what? Opposite side by hypotenuse. Here this is the hypotenuse, sorry, it is hypotenuse, it is opposite side and it is adjacent side. Sine theta equal to what? X by 1. What about the adjacent side? Root of 1 minus x square. Therefore, sine theta equal to x means cos theta equal to what? Adjacent side by, okay, tan theta equal to what? X by opposite side by, okay. See, sine inverse of x equal to theta and sin theta equal to x. Sin theta equal to x means cos theta equal to root of 1 minus x square. Tan theta equal to x by root of 1 minus x square. What about theta? So theta equal to cos inverse of root of 1 minus x square. Here also theta equal to tan inverse of x by root of 1 minus x square. See, here sin inverse of x equal to, here you took theta. Theta equal to what do you have in terms of x? Cos inverse of root of 1 minus x square or tan inverse of x by root of 1 minus x square. It means sin inverse of x can be written as cos inverse of root of 1 minus x square or tan inverse of x by root of 1 minus x square. It means what? Sin inverse of x can be expressed as or can be rated as cos inverse of root of 1 minus x square or tan inverse of x by root of 1 minus x square. Therefore, what about remaining? See, if you have sin inverse of x, then if you want write in terms of cos inverse, it means root of 1 minus x square. If you want write in terms of tan inverse, x by root of 1 minus x square. What about remaining 3 inverse trigonometric function? As you know that sin inverse of x and what is the relation between sin inverse of x and cosecant inverse of x? Sin inverse of x can be written as cosec inverse of 1 by x, because already we proved one property, sin inverse of 1 by x equal to cosec inverse of x, and cosec inverse and sec inverse can be written as sec inverse of 1 by root of 1 minus x square or cot inverse of root of 1 minus x square by x, because tan inverse of 1 by x equal to cot inverse of x. Already we proved first 3 properties. Therefore, sin inverse of x, one of the inverse trigonometric function, you you have to express into remaining 5 means you can write it as cos inverse of root of 1 minus x square, tan inverse of x by root of 1 minus x square, or cosec inverse of 1 by x, sec inverse of root of 1 minus x square, or cot inverse of root of 1 minus x square by x. In this way, you have to express one inverse trigonometric function into remaining 5 inverse trigonometric functions. Suppose I will take one of the example. Express sine inverse of 3 by 5 into remaining 5 inverse trigonometric functions. Express sine inverse of 3 by 5 into remaining 5 inverse trigonometric functions. How to write? Either you can use the formula just to prove that one, or again I want to take here sine inverse of 3 by 5 equal to take theta. 3 by 5 equal to what? Sine theta. If sine theta equal to 3 by 5 is nothing but what? If it is theta, 3 by 5, what about adjacent side? 4. If sine theta equal to 3 by 5, what about cos theta? Cos theta equal to 4 by 5. What about tan theta? Tan theta equal to 3 by 4. What about secant theta? Secant theta equal to 5 by 4. What about cosec theta? Cosec theta equal to 5 by 3. What about tan theta? Sorry, cot theta. So cot theta equal to 4 by 3. Say sinus of 3 by 5 equal to theta you took. Therefore, sin theta equal to what? 3 by 5. Again here, cos theta equal to 4 by 5 means theta equal to what? Cos inverse of 4 by 5. Tan theta equal to 3 by 4 means theta equal to what? Tan inverse of 3 by 4. Sec theta equal to 5 by 4 means theta equal to what? Sec inverse of 5 by 4. What about cosec theta? So theta equal to cosec inverse of 5 by 3. See, here you took theta equal to sin inverse of 3 by 5. You got theta equal to cos inverse of 4 by 5, or tan inverse of 3 by 4, or sec inverse of 5 by 4, or cosec inverse of 5 by 3. It means sin inverse of 3 by 5 can be written as cos inverse of 4 by 5 or tan inverse of 3 by 4 or remaining 3 inverse trigonometric functions. Are you followed how to express? If you know one of the inverse trigonometric function, then that inverse trigonometric function you have to express into remaining 5 inverse trigonometric functions. Is it clear? Now, one example I want to solve. Find the value of one of the example. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. Sine inverse of 3 by 5 plus cot inverse of 3 by 2. Find the value. See, here you don't have any formula of sin inverse of x plus cot inverse. It is nothing but cot. Okay. Suppose here in the bracket, if we have tan inverse of x plus tan inverse of y, here we have a tan is there outside. Therefore, tan inverse of term, any term equal to, again you can write directly. Tan inverse of tan theta equal to, so tan inverse of x equal to x directly you can write whatever that value will come. But here we have sine inverse and cot inverse. If you want to apply the tan inverse of x plus tan inverse of y, for that purpose you have to convert these inverse trigonometric functions in terms of tan inverse. It means sine inverse of 3 by 5 means what about tan inverse? Cot inverse of 3 by 2 means what about tan inverse? Just only you proved sine inverse of 3 by 5. Sine inverse of 3 by 5 equal to what? Sine inverse of 3 by 5. Here I took theta. Therefore, 3 by 5 equal to what? Sine theta. Therefore, if you draw the triangle theta, sine theta equal to what? Adjacent opposite side by hypotenuse, and adjacent is 4. Therefore, tan theta equal to what? 3 by 4. Therefore, theta equal to what? Tan inverse of 3 by 4. It means here you took this is equal to theta. You got this theta equal to tan inverse of 3 by 4. Therefore, sine inverse of 3 by 5 can be expressed in terms of tan inverse, means tan inverse of 3 by 4. Therefore, see, I want to take the question here. Tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2 equal to tan inverse of sine 3 by 5. Sine inverse of 3 by 5 means tan inverse of 3 by 4 plus, is there any relation connecting with the cot inverse of x? As you know that tan inverse of 1 by x equal to cot inverse of x, or cot inverse of x can be written as tan inverse of 1 by x. It means here cot inverse of x equal to what here? 3 by 2 is there. If you want to write tan inverse means 1 by x. 1 by x means it will become what? 2 by 3. Or by again drawing the diagram also, triangle. Okay, cot inverse of 3 by 2 equal to theta. Therefore, cot theta equal to 3 by 2. Simplify, will get again same. Therefore, now this is equal to tan inverse of, again it is in which form? It is in the form of tan inverse of x plus tan inverse of y. Therefore, we have tan inverse of x, nothing but 3 by 4 plus 2 by 3 by 1 minus 3 by 4 into 2 by 3. How I can write here? How I wrote this one? Because tan inverse of x plus tan inverse of y equal to tan inverse of x plus y by 1 minus xy. So therefore, this is equal to not here tan is there, not tan inverse. Therefore, tan of tan inverse okay, simplification of 3 by 4 plus 2 by 3. Okay, what is the LCM? 12, 4, 3 is 3, 4 is 3, 3 is 9, 4 2 is 8, 4 3 is 12 is numerator, denominator LCM is 12 again. 12 minus 3 2 is 6. Therefore, here we have tan of tan inverse of 9 plus 8, this 12, 12 get cancelled. 17, 12 minus 6 is 6. Therefore, tan of tan inverse of x equal to what? 17 by 6. Tan of tan inverse of x can be written as x by using this condition. 17 by 6 is the answer. Next question. Next is prove that 2 sine inverse of 3 by 5 equal to tan inverse of 24 by 7. Again, see here. 2 sinus of 3 by 5 equal to, you have to prove tan inverse of 24 by 7. How to prove it? First, I want to write this sine inverse in terms of tan. As you know that 2 sine inverse of 3 by 5 can be written as just I wrote in the last two examples already. We used this sine inverse in terms of tan inverse. So sine inverse of 3 by 5 equal to tan inverse of 3 by 4. See the last two examples. Then did I do know that because what you have to prove in the RHS side, we have a tan inverse. Here we have a 2 tan inverse of 3 by 4. Is there any relation connecting with 2 tan inverse of x into tan inverse? As you know that 2 tan inverse of x equal to tan inverse of 2x by 1 minus x square. Already we proved here. 2 tan inverse of x can be written as tan inverse of 2x by 1 minus x square. Therefore, here 2 tan inverse of 3 by 4 can be written as tan inverse of 2x, 2 into 3 by 4 by 1 minus x square, 3 by 4 square. Is it clear? 2 tan inverse of x equal to tan inverse of 2x by 1 minus x square. Therefore, here tan inverse of 2 1s are 2 2s are. Therefore, here you have 3 by 2, 1 minus 9 by 16, or this is equal to tan inverse of 3 by 2, 16 minus 9 by 16, 2 1s are 2 8s are. So, this is equal to tan inverse of 8 goes numerator 24, 16 minus 9, 7. Okay, this is equal to RHS. Tan inverse of 24 by 7 is the answer. Next question. Okay, one more important question is there. Solve tan inverse of 2x plus, because so many examples are there in the exercise 2.2 miscellaneous that they will not ask in the examination. For JW, you have to practice all example. You have to convert one inverse trigonometric function into remaining inverse trigonometric function. And you have to convert tan inverse. Again, you have so many formulas, properties are there that is not possible to prove it, because now we proved only tan inverse of x plus tan inverse of y. Like that, you have properties are there, cos inverse of x plus cos inverse of y, sin inverse of x plus sin inverse of y. Okay, so many examples are there. Okay, next one more question. Solve tan inverse of 2x plus tan inverse of 3x equal to pi by 4. Why I took this example also? Because this is not depend upon one inverse trigonometric function into another one, because this question sometimes they ask in the CET. So options what they will give and how to choose the answer also important. That is why I want to took this example. See, tan inverse of 2x plus tan inverse of 3x equal to pi by 4. Okay. Again here, tan inverse of x plus tan inverse of y equal to tan inverse of x plus y by 1 minus xy. Therefore, here we have 2x plus 3x by 1 minus 2 3 the 6 x square equal to pi by 4. Or take tan inverse that side, 2x plus 3x 5x by 1 minus 6x square equal to tan pi by 4. As you know that tan of pi by 4 equal to 1. Therefore, 5x by 1 minus 6 x square equal to 1, or 5x equal to 1 minus 6 x square, or 6x square plus 5x minus 1 equal to 0, or 6x square plus 6x minus x minus 1 equal to 0. Take 6x common here, x plus 1 minus 1 into x plus 1 equal to 0, x plus 1 into 6x minus 1 equal to 0, or x equal to minus 1, x equal to 1 by 6. See, so how many values of x will come here? X equal to minus 1 and x equal to plus 1. X equal to 1 by 6 here. One time they asked in the CET this example. Options they will give minus 1, 1 by 6, both minus 1 and 1 by 6, both, or any other one more option they will give. See, in that which one is the correct? Here we have, if you solve the quadratic equation, you will get two values of x will come. So is these two are the solution of the given inverse trigonometric function? See, suppose if you take minus 1 here, tan inverse of minus 2x, tan inverse of minus 3x. See, sum of the two angle equal to what we have? Pi by 4. Pi by 4 is what? 90 degree. Here, suppose if you substituting a value minus 1, if you substitute that LHS becomes also negative. But RHS side we have what? Positive. Therefore, how it will become LHS equal to RHS side. Therefore, minus 1, x equal to minus 1 is not one of the solution for this given inverse trigonometric function. Therefore, x equal to 1 by 6. See here, why I took this example, like this also they will ask in the examination. It means what? After finding the value of x, you will get two values of x, means whether they are correct or not also you have to check. Only we have one of the option, means you have to pick the correct answer. Suppose both options we have, it means you got that two values of x, then which one if option A is x equal to minus 1, option B is 1 by 6, means both of options looking same, correct only. But how to pick the correct answer? You have to substitute here in the given equation. So which one will get RHS, that is the correct. Therefore, x equal to minus 1 is not the solution of this inverse trigonometric function. Therefore, x equal to 1 by 6 is the correct answer. Okay. See, so this is the all about inverse trigonometric functions. See, if again they will continue the same syllabus like last year, it means reduced syllabus, means only they will ask 2.1. In that 2.1 also what they will ask? Find the domain and range of the inverse trigonometric functions and principal values of the inverse trigonometric function. Only two questions they will ask in the theory examination. Suppose they will keep full syllabus. See, only 2.1 means only two questions. two questions means one is 1 mark and one is for 2 marks. Two questions only they will ask. Suppose if they will keep full syllabus means that will be 8 marks. 8 marks means you have to simplify, you have to practice all 2.1 and 2.2. Already I told many times 2.2 exercise examples are very important for the calculus part. That is why I took all the questions of the exercise 2.2. Okay, so in the so after 2 days you have a weekly test examination. There also will ask a lot more example from exercise 2.1. Only one or two question only will ask from the 2.2, isn't it? So all the examples based on 2.1. And today what I solved that example like sinus of sine theta, theta is like that also very important. So don't think that that is only 2.2. So that examples also comes in 2.1 also. Okay, so that is why some of the question 2.1 and some of the question 2.2 sinus of sine 2 pi by 3 like that questions will ask in the weekly examination. You have to find the value of inverse trigonometric functions. Okay, this completes inverse trigonometric functions. Okay, so in the next class again new chapter, so we will start. Okay, thank you.